Hi, this is Joe with Scalar. Today we're going to talk about the Saga Pattern, but instead of using my voice, today I decided to use Bob, our AI voiceover, who personally speaking has a much better voice than mine, so please enjoy.
Hi, I'm Bob. Today, I'm here to talk about what a Saga Pattern is. When you're doing some online shopping, the expectation is that once you submit your order, the order gets processed and arrives at your designated location. Behind the scenes of a Saga Pattern, that seemingly single transaction of your order is broken down into smaller, local transactions. In this example, a single transaction touches 3 data points. The first, customer information, is where customer information is stored. The second, order details, is where product information and inventory information are stored. And the third, delivery date and time, is where various delivery information, timelines, and delivery services are stored. So, whenever an order is received, 3 separate data sources need to be updated. On a retail site which could potentially process tens of thousands of transactions per minute, how do you maintain data consistency across multiple data sources? This is where the Saga Pattern comes into play. The Saga Pattern is a distributed transaction approach in data architecture, where a sequence of local transactions, each managed by a service, coordinates to achieve eventual consistency across systems without a centralized transaction manager. What does this mean? This means that for every order that is submitted, there are multiple compensating transactions happening in the background, and only when the last compensating transaction is complete will the order actually be submitted. This is called eventual data consistency. So let's illustrate this. For example, in a Saga Pattern, when a user clicks on the Submit Order button, the application layer first processes the customer information through the customer process service. And then the relevant customer information is written into the customer database or table. Next, the application calls the inventory service, and similarly, the inventory information is updated. And when the inventory service is completed, the final step, the delivery process service, is triggered. And finally, the order is processed, thus getting to eventual consistency. The challenge and issues of the Saga Pattern is the intermediate state. So, what is the intermediate state? In the example, for every order submitted by the customer, 6 steps need to take place before the order goes through. The intermediate state is the state between a transaction while it processes all compensating transactions until the transaction is committed or rolled back. So, while the single order attempts to be committed, the data within the intermediate state is inconsistent. Any errors, such as network outages, database failures, or even inventory supplies not adding up, can disrupt transactions within the Saga Pattern. In a Saga Pattern, every single possibility must be manually coded for, even the unforeseen errors. This makes the Saga Pattern challenging. These errors and data inconsistencies will lead to financial losses, operational inefficiencies, customer churn, and falling behind in innovation. Scalar DB is a new way to manage your data architecture, which avoids these inefficiencies and data inconsistencies. We define the future of data management. Check out our other videos to learn more about how we bring value to our customers by helping them save time, money, and resources.